I pulled together a group of very talented scientists and engineers, and my partner and I, which is Townsend Capital. They are a Maryland-based venture capital group. Very successful, very talented group of people. They also have, by the way, huge investments in the field of energy efficiency.
Okay.
So they understand this business, and they've been investing in this field. And we got together, and Dennis Townsend, who is the founder of that group, had ideas, and I had some ideas. We put them together, and they came up with this proposal to set up a company. Let's do it.
Okay.
What the industry needs.
Yeah. Well, so let me ask you then. So the chemistry. Are you telling me then that you're looking at your sort of basic chemistry being similar to a lead acid battery, or are you looking at materials that are as inexpensive as lead acid batteries?
It is basically it is a lead acid chemistry.
Okay.
Is we are enhancing and improvising the performance characteristics of this chemistry by making some modifications to the materials, to the microstructure, the way the battery is made, its design, and how we put it together. So the bulk of the battery cost still relies on the lead chemistry, but we made some changes to the design of the battery and the materials to achieve, for example, we have achieved 4x the power density of a normal lead acid battery.
Okay.
Without compromising the energy density of the battery, and without adding any cost to the base cost structure of lead acid chemistry.
Okay, so what you're looking at then is, I'm gathering from what I've read prior to our talk here, is that you're doing something, your initial focus is for the time being on doing a power battery essentially for microhybrids. Is that correct?
Microhybrids and hybrids.
Okay.
So
what's sort of the kilowatt hour range of what you're looking at? I mean, the typical microhybrid somewhere around 500 watts. The Prius is up around 1.3, 1.4 kilowatts.
So Prius is 1.3 kilowatt hour.
Right.
And that's considered a full hybrid.
Right.
So we're looking at anywhere up to 2 kilowatt hours on board a vehicle, and within that 2 kilowatt hours, you cover all microhybrids, all mild hybrids, all full hybrids, all the way from start-stop to, let's say, vehicles like Prius.
Okay, so with that capability, then what you're looking at is that power. You're going up to that 2 point to give the car what? Improved acceleration and larger regenerative energy capture? Go ahead. Yeah, go ahead.
So what we're doing is we're not changing the powertrain architecture. That's
right.
What the car company do. What we're doing is we are offering an energy storage system with extremely high power capability at very low cost for the car companies to be able to make those powertrain for hybrid vehicles. What we're doing is we're saying we have a battery which is roughly, less than the cost targets that OEMs have for advanced battery technology for hybrid vehicles. So, say $250 a kilowatt hour. You have 1 kilowatt hour battery on board your vehicle. It's $250 plus some system integration costs associated with that, as opposed to that cost being 4x or 5x
right.
For other technologies.
Right. So what you're, I guess I'm trying to wrap my head around here. You're not wanting to you're not wanting to build a car that's got 12 miles of electric driving range like a plug-in Prius. What you're looking at is something in the neighborhood between a Buick with e-assist that's got a 500-watt battery and up to the conventional sort of Prius with its larger battery. And that those batteries are in there essentially to sort of allow the car maker to downsize the engine and pick up any additional acceleration power from that built-in energy that's in the power battery. Is that right?
So the easiest way to demonstrate my point is you take Prius, for example. It has good fuel economy, it has certain range, it's not a plug-in, it's a hybrid vehicle. All we will do is our solution will cut the size of that battery in less than half, cut the cost of that battery by a factor of 3.
Oh, by a factor of what was it? I'm sorry?
3.
3, okay.
So that's the value proposition.
Right.
So in other words, I'm saying I'll give you the same performance that you're getting from nickel metal hydride, 1/3 the cost and less than half the weight, less than half the size of the battery.
Okay.
Because this technology doesn't require all the sophisticated thermal management system that nickel metal hydride technology needs or lithium-ion battery technology needs, as you have been seeing and reading in the newspapers about the very complex thermal management system for vehicles that use lithium-ion battery technology.
Right, yeah.
So that's one aspect of what we are doing. Now, as I said earlier, that our partner, Townsend Capital, has investments in energy storage and energy efficiency technologies in their portfolio. So they're also, they have a major stake in a partnership with Dow Chemical, a company you know, Dow Chemical.
Right.
So we are also working on methodologies to combine the high energy lithium-ion batteries with our high power EPS battery to provide a complete hybrid battery solution for vehicles that require more than 2 kilowatt hours of energy on board. So now if you move towards the right side of the curve, say plug-in hybrid, PHEV 10, PHEV 20, PHEV 30, 40, or 50, like Chevy Volt, now we can provide a solution which is a combination of high energy lithium-ion batteries and high power EPS battery, reduce the overall size and the cost by a factor of 2.
Okay. So let's take the Volt for example. The Volt's got a 16 kilowatt battery pack in it.
Right.
Using, and that of course is, I'm gathering, they've tweaked that battery to be essentially an energy battery to get that 25 to 50 mile EV range, but there is some power capability obviously there as well for acceleration. So if you're going to take, for example, the Volt battery at 16 kilowatts and you would hybridize it where you would have the energy piece of the battery, which would still maybe be LG Chem, but then there would be your part of the battery. What would that ratio look like in terms of either the size of the pack being reduced or the weight of the pack, that type of thing?
Well, if you use Chevy Volt as an example, that particular battery is not optimized for energy or power. It is optimized for both because it needs both. It needs power and energy.
Yep.
It is when you try to optimize it for energy and power, the cost of the battery goes up. You're using a lot of expensive components like copper and cobalt, whereas if this battery was to be optimized only for energy,